Let's look at questions 13 through to 15 then. Which statement about E12 Dichloro Ethene is correct? So let's have a look at what E12 Dichloro Ethene is. So ethene 2 carbons, joined with the double bond, the ene, and I've got a Cl, 2 Cl's dichloro, 1 Cl at number 1, at carbon number 1, and 1 Cl at carbon number 2, so they're on opposite carbons. Because there's a double bond, there's no fixed rotation about the double bond, and if you look to the left of the double bond you've got H and a Cl, and to the right of the double bond you've got an H and a Cl. So to the left of the double bond you've got two different groups, an H and a Cl, and to the right of the double bond you've got two different groups, a H and a Cl as well. So it's going to have geometrical isomerism, which is a form of stereoisomerism, and it will have E isomers where the Cl, the atom that takes highest priority because it's got the highest atomic mass, can be at the top or at the bottom. If one Cl is at the top of the carbon-to-carbon double bond and one is opposite on the bottom, it's an E isomer. If they were both on the top or both on the bottom on the same side of the carbon-to-carbon double bond, it would be a Z isomer. So it has the same boiling point as Z. E and Z, do they have the same boiling points? Do the positions of the Cl being either up or down affect the boiling point? Well, yes, they do, because a C to Cl double bond is polar. It's got a delta plus and a delta minuses, and if both of those polar bonds are on one side of the double bond, it will affect the dipole-dipole attractions, the intermolecular forces between the molecules, and it will affect the boiling points. So E and Z will not have the same boiling points. It forms a polymer with the same repeating unit as Z. Well, in actual fact, I think that one's true, because the carbon-to-carbon double bond breaks and forms single bonds. So once they've formed single bonds, there is no fixed, the positions, the atoms are not fixed in positions in space, because a single bond does have free rotation. So the Cl's are free to move up and down because the carbon-to-carbon single bonds can rotate. So it's no longer fixing the positions of the Cl groups in space, and therefore the repeating unit will be the same irrespective of whether it's come from an E or a Z isomer. It has the same infrared spectrum as Z12 dichloroethane in the range 400 to 1500 centimeters cubed. Well, we haven't got anything in that range anyway. A carbon-to-carbon double bond is 1620 to 1680, so that range is wrong for a start. It has a molecular ion peak different from that of Z. Well, what happens is in molecular ions is that these molecules lose an electron, and when they lose an electron, then they get a positive charge, and the positive charge then is called a molecular ion, and you can measure the relative formula mass of that ion. Well, it won't actually affect E or Z are going to have the same MR. So when you form a molecular ion, it's the positions of these Cl's which are different between E and Z. They've got the same relative formula mass, they've got the same MR, and therefore the molecular ion won't be different between these two. So D is wrong. So your answer there is B. Which statement about ethene is correct? It has no geometrical isomers because there's no free rotation around the carbon-to-carbon double bond. Well, that's true in that there is no free rotation about the carbon-to-carbon double bond, but it's not the reason that this has no geometrical isomers. The reason it doesn't have any geometrical isomers is ethene, so it's carbon-to-carbon double bond with two H's to the left of the double bond and two H's to the right of the double bond. If you look to the left of the double bond, you've not got two different groups, you've got two H's, and to the right of the double bond, you've not got two different groups, you've got two H's. So the reason it doesn't have geometric isomers is because there are two groups which are the same to the left of the double bond, and also two groups to the right of the double bond which are the same. So that's the reason it doesn't have geometrical isomers. It reacts with HBr in a nucleophilic addition reaction. No, it reacts with HBr in an electrophilic addition reaction. So nucleophilic is wrong. So nucleophiles such as OH minus or Br minus would react with something with a slight delta plus. So a double bond which is high in electrons is electrophilic addition. It burns in excess oxygen to produce carbon dioxide and water. Yes, any hydrocarbon will burn in oxygen, excess oxygen that is, to produce carbon dioxide and water. The word excess is important, so if there's not a plentiful supply of oxygen, then it would be incomplete combustion rather than complete combustion. There'd be incomplete combustion, and it may form something like carbon monoxide or even carbon as a black solid. But in excess oxygen, it will produce carbon dioxide and water. So C is correct. The C double bond is twice as strong as the carbon to carbon double bond in ethane. Well, you can't make that assumption. In actual fact, that's not true. The carbon to carbon double bond isn't twice the strength of a carbon to carbon single bond. Which statement about ethanal is correct? So ethanal is an aldehyde, CH3CHO. It reacts with toluenes to form silver. Well, that's true straight away. An aldehyde does react with toluenes reagent to form a silver mirror. It would also react with failing solution to form a brick red precipitate. It has a higher boiling point than ethanol. Now, ethanol has an OH group, so an oxygen bonded to a hydrogen. Anytime that you get hydrogen bonded to an oxygen, or a fluorine or a nitrogen atom, then that is a very polar bond with large delta plus and delta minuses, and therefore the dipole-dipole attractions between molecules is very strong. That's something called hydrogen bonding. So when you get H bonded to an O, an F, or an N, then you get hydrogen bonding, which is the strongest form of intermolecular bonding, and that's what ethanol will have. So that'll have a high boiling point, higher than ethanal, which has just got polar bonds and dipole-dipole attractions between the C double bond O, which is a polar bond, and other C double bond O's of sort of nearby molecules. Its empirical formulas and molecular formulas are different. No, they're not. They're the same. You've got CH3CHO, so the molecular formula will be C2H4O. Since it's got one oxygen in it, you can't simplify that to form a simpler empirical formula. It belongs to the homologous series with the formula CnH2NO. No, we've just said it's C2H4O, so it will be CnH2NO. So A is obviously your correct answer.